functions. We're going to start with the graph of 1 over x.
I watched one of your videos.
And I sound like a girl.
You sounded like you were sucking on hydrogen or something.
Yeah, I know.
Funny.
So there's the graph. This is a parent function. So first I'm just going to rehash parent functions and what we can do with it. We're going to talk about end behavior. Okay, so some review things that we've been doing. And then we're going to touch on vertical and horizontal asymptotes and how to actually find those lines. So if we're going to talk about end behavior, as x approaches infinity, what does y approach? 0. And negative infinity is the same.
How does y approach 0?
Well, the y is the up and down, right? So as we come out to negative infinity, we're getting closer and closer to 0, but we never touch it. On this one, it will never touch it. So think about it numerically. If x is 1 million, way out here, right? Yeah, it's like 0.0000001. Is it 0? No, but it's darn close. Okay, so we say it's approaching 0, but it's never going to get to it. Okay, this tells us there is a horizontal asymptote. What's the equation? Yeah. The horizontals are always y equals. Okay. And then we can also do as x approaches 0. Anybody know what that little negative means? Yeah. Yeah, from the left. Yeah, that's what the 0 or the negative means there. So we're approaching from the left or the negative side. Y goes to what? Try again. Negative, thank you. Okay. We're coming to 0 from the left. Correct? And that's going to negative infinity. So we're following the line towards 0. From the left is going to negative infinity.
So we have 2 end behaviors?
2 what?
2 end behaviors?
Yeah.
Okay.
4 really.
Well, yeah.
1, 2, 3. And then what is this one? As x approaches 0 from the right, y approaches the infinite. That tells us we have a vertical asymptote equation Anybody? You betcha. Okay, that's the parent function. Any questions? Alrighty then. What does the graph of that one look like? Translated to the right 3, because it's with the x on the bottom, so right 3. So we just draw a new asymptote, 3 units, and it's the same shape. It would be a stretch, like multiplying by something. What about, give me a small single digit number. That one does what? Yeah, up to. Outside of the x, outside of the fraction there, so up to. All you do is take the parent and move it up to. What? I'm just going to ignore you for now. Okay, we on board with the review of that? Okay. What if FG, let's call this one H. Negative. What does the negative do? Thank you for using your math language. So we're going to reflect it over the x-axis. It looks like that. So we take the original and flip it over the x-axis. You want to see one more? And try. Okay. Okay, if you have like something like 2 over x, or it stretches it vertically. Okay. Are you good there? No as in I don't get it, or no as I'm still writing? We've been doing parent functions for 2 weeks. Why haven't you come to see me?
I think we're not understanding the stretch part.
Okay. If I put 1 in for x on the parent function, right? The output is 1, so I have 1, 1 as a point, yeah? Okay, now if I put x in for 1 here, it's 2 now. So it's taken that original 1 and stretched it up, vertically stretched it, okay? It hasn't moved the asymptotes, but it's stretched the graph vertically. Yes now or no now? Okay, so we're moving the y values up higher, so it stretches it. All right, now to the meat. How to calculate asymptotes. I'm going to show you how to mathematically, algebraically calculate the equations of the asymptotes. Okay, your key here for vertical asymptotes is a possible vertical asymptote when the denominator is 0. We're going to have to test to make sure it is. What x value are we looking at? X equals 1. 1 minus 1 is 0. Okay. You're always confused.
I know, I told you it should be in class.
That's not what I'm talking about.
I don't get it.
How about we just prove my point even more? Okay. If I plug 1 in for the denominator, what's 1 minus 1? Okay, so 0 in the denominator means the fraction is undefined. Means we cannot be in that spot on the graph. Okay, so at x equals 1, there's a possible vertical asymptote. Okay, we're going to test for it. It could be a hole. That's what we're testing for. It's either a hole or an asymptote. Okay, so we have to check from the left and from the right. These are what we're calculating the limit from the left. So we have 0.9. It's the same thing we did with continuity. So we're getting closer and closer to 1 from the left. And closer from the right. So we're either going to see them approach the infinite. Okay, that'll give us a vertical asymptote. Gabby.
So asymptote means they're always approach one, but never.
Yep. Are you with me on what we're doing? We're checking, so if, okay, this is a big if, there's a vertical asymptote at 1, this is going to do something like so. So we're looking for, as we come from the left, probably going to approach negative infinity. And from the right, probably going to approach infinity. They're going to 2 different spots. Okay, this is what we're looking for. So if you guys remember that calculator trick I showed you? So plug. Plug it in. Plug it in. Plug it into the equation. The longest one. And then second entry, and just delete 1. Okay, so I have an entry in there, right? I did 0.99. Yeah?
I typed the same exact thing in, and I had that.
Did you put the denominator in parentheses? I don't know what to tell you then. I will come look. Okay, who's having trouble?
On the computer? Now go delete.
I'm going to sleep.
Genius, right?
Well, yes, 8 years ago. It's more than that. I've taken that.
Now, this is on the test. If you don't know how to do it, you're going to miss some points. Okay. From the left, what is y approaching? No. They're growing really fast. Okay. Now do it from the right.
Yeah.
What is this one approaching? As we approach 1 from the right, this is going to infinity. So we have exactly what I showed you on the possible graph. Yay! Okay, are we on the same page? Or did you use 2 sheets of paper for that one?
Front and back. I'm not for that one.
You have to be able to do this on the test. I'm just telling you right now. It could be within the definition of continuous, or it could be in this situation. You do not have to do it. You have to know how to do it.
can you put your calculator back
Yeah.
or did you delete it?
Sorry.
Wait.
Here's the last entry I did, if that helps. Okay, so we have a vertical asymptote. Okay? Can I move on? I got 1 0 and 25 of those.
Wait. So I have a question. How do you know that's an asymptote, not a whole?
Because as x approaches 0 from or 1 from the left, y goes to negative infinity. As x approaches 1 from the right, y goes to infinity. So we're going up and down.
Okay,
So it has to be an asymptote. If it was a whole, it would go to a specific number.
I have no idea. I just don't understand. It was in my head. I didn't know if you were. I don't think you don't understand what
Are we confused, so we're just ignoring the issue, or are we just being social? Okay, this is not telling me very much. Yeah, I'm getting feedback from a couple of you, but
I'm getting better.
okay. You're putting these numbers in the equation. So 1.1 divided by 1.1 minus 1. That's 11. Then 1.01, put it in. You get 101. What I showed you on the calculator is just an easier, faster way to do it. If you need to do each one separately, that's fine. It'll give you the same answers.
Wait, we use those numbers because we have to go somewhere and go to one, right?
Right, so yeah, we're going from like 1.1, 1.01, we're getting closer and closer, but never touching it. Okay, we cleared a couple of them up. Okay, horizontal asymptotes. There are two different possible methods. Gabby, if it what?
Like the first one, you said that it was
Yes.
possible. So how do you-
Okay, so the other possibility is a point discontinuity. That's the other possibility. Is there a vertical asymptote there? Okay, so this would say as x approaches 1 from the left, y would go to 4. As x approaches 1 from the right, y would also go to 4. So you're coming to a specific spot on the graph as opposed to trailing off into the infinite. That's the other possibility. It's called a point discontinuity. It happens when it looks like this. Can I factor the top there? What do you notice?
right here.
Yeah,
So there's a 0.
that's when a point discontinuity happens. Yeah. I should, but right in the middle of something. It's a fellow teacher. Okay, so that's when a point discontinuity occurs. Okay. There's the difference. Does that answer your question? All right. It would be at 1, yeah. On this one, the point discontinuity would be at 1. This infinite discontinuity is also at 1. Similar situations, but different results. Okay, horizontal asymptotes. Okay, we have to solve this for x. Okay, those obviously cancel. So we get going to distribute. And get xy minus y equals x. We still have a couple more steps to do. Because x is not, there's still a couple of them hanging out. We're good so far? Okay. I'm going to move the x over here and add the y to this side. Okay. Danny, do you have the homework assignment written down? Okay. You can watch the video if you want. Finish up. Are you okay? You still with me? Okay, we're going to factor. Yeah.
If you move x,
Because I moved this y over here. So I had to add it, so those cancel. So it becomes positive y over here. Then I subtracted x, those cancel. Now it makes it minus x over here. X minus x is 0, so it's gone from here. But xy minus x over here. So I just factored an x out. Divide by y minus 1. What? I know that. It doesn't work every time.
But it goes like that.
If it's that exact equation, yes, it works. No, you can't just flip x's and y's. That's calculating an inverse. Okay, we can't just do that. So you have to solve for x. What is the horizontal asymptote? Y equals 1. Now that's a guarantee. Put a rubber stamp on it. Bam. Works every time. As long as you can solve for x. All right, there's another method that I think is easier. Hey. Okay, what's the highest power of x? Yeah, it's x to the first, right? Yay. Leave a space. I am going to divide each term by that x. Okay, so use the highest power of x and divide it into each term. It doesn't do anything for you. Okay, what's x divided by x? And x divided by x? That's the same. Okay, what happens as x approaches infinity with this one? 1 over x goes to x gets bigger and bigger, that goes to 0. So we can basically just discount it. Why? What you've done, basically you're analyzing the end behavior of this graph on a horizontal axis. Okay, you're going left and right. As x approaches infinity, that right there goes to 0. So what you're left with is y equals what? There's your horizontal asymptote. Yeah, me too. All you have left is 1 over 1. Yep. It gets a little more complicated, but we save that for calculus. Yep. Okay. I suggest you start You know, 5 and 6 are what we just did. If you have troubles with those, you might want to start there. 1 and 7 are parent function translations. You could start there. But make sure you get a couple done in the next 10 minutes. It's work time. There's the homework. I wrote it down yesterday too.